Hello guys, what's up? We are back again with another question from our level up series. So guys, today our question is remove invalid parenthesis. So let us first understand what this question states. So in this question, we will be given a string S and we need to return list of unique strings that are valid because that is their arrangement of parentheses is valid with the minimum number of removals. And also we can return answer in any order. So essentially we need to return a list of valid parentheses. But we also need to make sure that it is following it is made by removing minimum number of removals. So that's what that question states. For example, if this is the string, then if I remove this, then this becomes valid. Else, what else? If I remove this, then this becomes valid. So this way, by removing just one, I could make the string valid. So this question is based on, you would clearly see or would get to know that this question is based on trying all possible ways. There is no as such straightforward greedy approach. So for example, if this is the string, then we do not need to consider the alphabets. We just need to cater brackets. So that is also a thing. Yeah. So first thing is very much clear that we only need to cater brackets. And second one is, it is very intuitive that we need to try all possible ways out. So this question clearly then boils down to optimization, as it is marked as hard. So clearly there has to be something apart from trying all possible ways. Then let us understand how we can approach this problem. So initially we will have this string. Initially we have this string. So if I go for the brute force, then for every bracket, either I will have it or I will not have it. Either I will have it or I will not have it. So this is how I will do it. Now, if I do not consider, initially I do not know what is the minimum number of removals, then I need to, whenever I reach a valid string, then I need to check whether the number of removals were minimal or not. And I need to update it every time. So that is also, so this is the brute force approach. So what would be the brute force? Brute force will be to try out each bracket, right? Pick and not pick, and for minimum, for every valid string, check the minimum. Check the number of parentheses you removed. Then if it is minimum, then update the answer. Likewise, you can do that. So we need to clearly optimize it. This will go up to 2 raised to power n and more, because we are also having a check. Now let us see how we can optimize things. One very obvious optimization is, can we know the minimum number of removals? Yes, we can actually know the minimum number of removals. Just think of this problem. Okay, let me just, yes. For example, first of all, consider that it was a standard, it did not have any kind of inconsistency. It was a consistent problem. it was a consistent string, then a stack would have been emptied if I did something like this. I just entered the opening brackets, and if I encounter the closing brackets, then I just crossed it. So this way I could check. This way, yes, I could very, very easily check if my minimum number of operations I would require. So how will I check it? I will have a stack. If I get a opening bracket, I will push it into the stack. If I get a closing bracket, sorry, yes, if I get a closing bracket, then I will pop it from the stack. And if stack is empty, I will make the invalid collections. And also, if the stacks is not empty after the whole process is over, then I have to add that much invalid also. So yeah, so this was the way we can actually know what is the number of invalid, minimum number of removals we need to do. Now we need to find out how many, we need to find out such strings. Okay, so let us see what further we can optimize. What further we can optimize is that we can have a check on right invalid and left invalid. That means number of left invalid, maximum number of left invalid brackets, and the maximum number of right invalid brackets, which can be possible in the given string. Yeah. So that is very obvious. How we can find it? We can find it in the same algorithm which we were using to find the number of invalid ones. So if I encounter this, then I will first of all increase the left invalid. But if I encounter the right invalid, then I will, sorry, if I encounter the closing bracket, then I will increment the left invalid. So then when will be the right invalid incremented? If there are no more left invalid or left brackets, to be precise, then I have to increment the right invalid. So this way I can find out how many left invalid and right invalid. We will see how these are useful. One more thing we can find it out is that we can count the left and right. We can have a count of left and right. Why? Because why it can be useful? It can be useful as if I encounter a, let us say, opening bracket, and I know that my right count, that is the count of right, or you can say the closing bracket count is 0. Then do I need to consider it further? Is it not invalid? Yes. It is invalid. So I won't consider it further. Hence, this will save me a lot of function calls. So now let us see the code itself, the main function, and you will understand what I am saying about. Yes. So if the minimum removals are 0, then I need to check. We already find out how we are finding the minimum removals. Then here I am making sure that it is not repeated. So this I checked, and then I pushed it back into the answer, and I returned from it. Now if I is equals to n, then again you have to return because it is out of bound. This is the not pick. So I am not picking means I am not considering this as invalid. So I am going as it is. But if I am considering it, then I only need to consider if it is either a opening bracket or a closing bracket. Okay. So I'll consider it. Now you will understand why these things were important. So if it is an opening bracket, but let us say right count is greater than my left count, then there is no need to evaluate or call the function. So I'll directly return from here. Also, if it is the opening bracket, but there are no invalid brackets left, that is left invalid is less than or equals to 0. So that means I have removed them. So I won't go further. Fine. Yes, same goes with this one. If it is the closing bracket and right invalid is less than or equals to 0, then I need not remove it. I'll just return. Now, what I will do, I will simply erase. So these two conditions are not met. Then I will erase that. That means I'm not considering it. And if it was a opening bracket, then I will do a left count minus minus, left invalid minus minus, because I have removed it. So left count also decreased, and I have removed one invalid bracket. So left invalid also decreased. Then I made a function call with minimum removal minus 1. And then of course, it is backtracking step. Then I will increment if I consider in order to consider all possible possibilities. So finally, I'll insert it back the element. So yeah, guys, this was all from this question. We are trying to try all possible ways, and we optimized it by using left invalid, right invalid, that is the number of invalid parentheses left, and left count, right count, that is the number of parentheses actually left. Okay. So yeah, guys, this was all from this question. Thank you so much, guys. Make sure you hit the like button, press the subscribe button, and share with your friends. Thank you so much, guys. We shall see you next time.